All right, it's 1 o'clock, so we'll kick off our session today. Hello and welcome everyone to our first Redfish webinar. Today we'll be talking about the Redfish 2020.4 release materials, and then have hopefully a lot of time left over for open Q&A. My name is Jeff Otter. I'm with Hewlett Packard Enterprise and one of the co-chairs of the DMTF Redfish Forum. And with me is Mike.
And I'm Mike Ranieri. I'm from Dell, and I am the other co-chair of the Redfish Forum.
So with that, we'll jump right in. Just a quick note that this webinar is being recorded. We will make a recording will be made available to the public on the DMTF YouTube channel, and the link is there, and also obviously works if you search for it. So jumping right into the topic for today, the Redfish Release 2020.4. This was approved by the DMTF Redfish Forum back in December, and after a 30-day review period that is required by our process, it was made available to the public in mid-January. So hopefully some folks have been able to already download those materials and maybe take a look at some of the what's new. And if not, that's why we're here today, and we'll get into the any questions about that, or really just in Redfish in general as we go through. So as is typical for a Redfish release bundle, we have a couple different deliverables that tend to get updated on a fairly frequent basis. Normally 3 times a year. In 2020, we actually did 4 releases. The first part of that release is the actual specification document. There were 2 versions of that came in this cycle. The first was just an errata version that added clarifications or other other corrections and clarifications to the specification, and so that has been made available as version 1.11.2. And then in addition, Redfish specification version 1.12.0 was a minor revision that added some new capabilities around restricted role and restricted privilege concepts, and we'll talk a little bit about those. The main item for really any of our release cycles is the Redfish schema bundle, and so that had been revised to version 2020.4, and that schema bundle, which is delivered as a zip file that can be downloaded, and it's under that file name of DSP8010. This was revised and includes 7 new schemas, and we'll talk about those here today. And there were also 29 schemas that had minor revisions, and so new properties. We won't go into that level of detail today, but if you go to the website, you can actually download this presentation that also includes slides that go into the details for each of those updated schemas. And then lastly, in this release cycle, we also updated the message registry bundle. And again, this is a zip file that contains all of the published message registries that are used by the Redfish specification and by implementations. So there was some additions to the base message registry for supporting new functionality that was added in the schemas. And in addition, there were 2 new registries, one for fabric and then a more specific registry for Ethernet fabric messages. Those were both released as their first version 1.0. All of the materials for Redfish, all the standard, either the standards documents, the schema files, all of our white papers, any other pieces of material are all available at the DMTF's website at the link there shown at the bottom of the page. And the other materials, and as we'll talk about, the open source products that are made available and from the Redfish Forum, those are available on the DMTF's GitHub organization, and I'll have links for all of those things here later in the presentation. So the first thing to note about the items in this release cycle is a concept that we had to enhance in the schema files themselves, and this had to do with new work that was coming out as part of this release, where we actually are migrating from old definitions to new ones, and so there are three schemas that have been deprecated by this release, and I'll get into what that means here in a second. The three of note here is the power schema, the thermal schema, and the network port. These have been replaced with new functionality, and in these cases, these were pieces that have been around since the original Redfish 1.0 release. And as I get into some detail on that, there was a lot of reasons for those moves, but rather than doing a version 2, an incompatible version, bump on any of those schemas, we felt it was just better to come up with a new, version 1 of a new schema, and allow them to coexist. So what you'll see in the schema files themselves will be terms that have that were previously defined but have never been used to deprecate an entire schema. And that's now visible in the schema files, and I've got listed there, whether it's the CSDL, the JSON schema, or the OpenAPI YAML formats of those schemas. You'll find this deprecated term that will show up at the root level of the schema, showing that the entire schema has been deprecated. Now, what that means for implementers and users is that new implementations, we're really encouraging you to go migrate to use the new definitions, as they fully replace the functionality that had been made available in those in the previous schemas. But there are certainly a large number of products in the field today that support these old schemas, and we're not looking for for folks to break any compatibility with existing clients. And so you can absolutely have both implementations coexist. So you can have the Power and the Power Subsystem, and I'll get into those details. You can have those implemented side by side. The overhead for an implementation is not too bad, and we'll see why when we get into it. But we certainly encourage, if if you're doing a new implementation and you're not having any reliance on existing clients, existing software that that use the existing power and thermal schemas, then you can avoid those implementations altogether and just go to the new ones. Speaking for my own products, I know that we have a lot of history with those schemas, and obviously a lot of customers that will rely on them. So we're expecting we'll be carrying the implementations of the old power and thermal, as well as the new implementations for some amount of time. And obviously we'll let the users give us the feedback on when it makes sense. So let me get into the details here. So the new Power Subsystem schema, this replaces the existing Power schema, and it improves the definitions, and it really shows the amount of growth in both our own learnings about what works and what doesn't, or what's difficult and what's easy, but also the increase of scope of Redfish and the depth to which folks can manage the various subsystems and all the componentry. And honestly, it had just the power and thermal schemas both, they had just grown too old. So it was basically, it was just too much now to keep carrying forward and adding more things when it was becoming more and more difficult to support those. And so it was really just time for us to make a break and say, hey, if we could start over and use what we had applied in the last 5+ years of Redfish work, what would we do now? And so that's really what we got. And so the Power Subsystem is a new schema. It replaces that Power schema, and it really is becomes the core of all of the related power entities, or power components that are within a chassis. So that it mostly provides links. There's only a few properties there. It's really there to lay the groundwork for future expansion as we get more and more power related equipment into the system. But the main thing that it does was to move the power supply, which power supplies have a large amount of detail available to them, and there's certainly a lot of dynamic data as well as a pretty good set of static configuration data. So we wanted to get that separated out and to also make it look like the rest of the Redfish schemas. So power supplies have now been moved to a resource collection. So each power supply gets its own resource. There's a separate power supply metrics resource that are related to each power supply. And that was done to separate the dynamic data, all of the voltage and current and, frequency and, temperature, everything about a power supply that can be used for either pulled or, for generating metric reports, but keeping that separate from the large quantity of static data that, that talks about the configuration of the power supply itself. So those are now all broken out, hopefully to align better with use cases, for client software. The good news is that within those new schemas, the actual property level definitions are mostly just copied unchanged from the previous power schema. So, under power supply, there's a part number, there's a serial number. Those are all named the same. So there were only a few cases where, definitions had either been, poorly named or defined, or things that we had, had to leverage and be consistent with work we had done in the PDU models and the circuit model. So we tried to make ourselves aligned with the latest work so that we go have better consistency going forward. But as an implementer, if you are migrating from Power to Power Subsystem, and the same will be true from thermal to thermal subsystem, it will all look very familiar and and should be mostly a bunch of block copies and not wholesale throw out and start over from scratch. So like I said, the thermal subsystem is a similar migration. It replaces the thermal schema with a new definition that allows for a lot of links and subordinate resources to separate the various components and allow them to grow and also have be formed in collections so that it looks like the rest of the Redfish model. So there is the first one that was added to the thermal subsystem is a fan collection. So each fan gets its own resource, and again, just like as the power to power supply migration, down at the property level, everything will look very familiar, if not identical, to the existing definition. So again, it should be a lot of copying and moving, not wholesale rewrites. So separately, and again, just like we had on the power supply metrics, there is and this is a more global thermal metrics resource. This as a start, we focus just on temperature readings, but within the thermal metrics, there's actually two structures. There's one that's a summary of temperature readings, and those have been given specific sensors with specific names, and obviously every implementation can map those values to to the sensors that it makes sense for for your implementation. But the idea was to give the client software an ability to very quickly and and deterministically navigate to whatever sensor you deemed as the one that was reflecting the ambient temperature or the intake or the exhaust temperature. So we gave those specific names, and then so if you have if you have a sensor that fits that criteria, then you have that temperature, and if you don't, then that property is just not populated. But this prevents clients from having to go, look through a large quantity of sensors, looking for the physical context of ambient to find the one they cared about. So this was trying to make client use cases very common and make simple scripts able to to be written that didn't have to do lots of array parsing and iterations. But in addition to that structure, there is an array of every temperature sensor. So it also provides every reading together. And so if what you were looking for was that full a full gamut of every sensor available, you get that as well. But again, there's not a lot of extraneous static data that's provided there. There are links to the sensor resources that back those readings up. So if you need to see, the individual thresholds, all the other, information about the sensor and the physical context around them, there are navigation links to take you to those. But we try to keep, the thermal metrics resource to be, very much focused on the readings themselves and not so much the static data. So lastly, in the new batch of schemas is one called environment metrics. So this is a common schema that we expect to go sprinkle around the model wherever a device or a subsystem has has things like a temperature sensor or a power reading. And so we made one definition for these things. And so you can see the list there. This energy, fan speed, humidity, power, and temperature. And obviously we can add more sensor types as as folks come up with them. But basically this provides a consistent naming and and schema definition for these commonly available readings. And so you'll see that we've added the environment metrics as a subordinate resource onto things like drive and processor and memory. So really at the early stages here, it's meant to be the consistent way to read those types of dynamic data for sensors around a specific device. But we expect that we'll apply this same schema to a number of other places over time as folks request it and as we discover other use cases. So just like the other uses in the temperature metrics and the power supply metrics, this resource is very sparse with with just the readings of the sensors themselves, and then pointers off to the individual sensor resources that back those readings up and all the metadata that go along with it. And so that uses the schema excerpt concept that we introduced a year ago. But you can follow those links, and it should be pretty straightforward to understand what's going on. So just to summarize the migration, if you are familiar with the power and thermal schemas that have been available since 2015 or have implemented those, this is kind of a quick summary of how you migrate those to the new to the new power subsystem and thermal subsystem. So the power and thermal resources, they get completely replaced. So you can drop that support whenever the market allows you to do so. In the thermal area, the fans, which was an array, those become a resource collection. The same for power supplies, which was an array in the power schema, that becomes a power supply resource collection. And then as I just said, the power supply metrics is a separate resource, but that is supported to each of the power supply resources. Voltages and temperatures, those become sensor resources. And so they'll show up under the chassis sensor collection. The temperature readings, as I just said, those get summarized in the thermal metrics resource. The voltages, the ones that are related to a power supply, those show up in the power supply metrics. There are some other use cases for voltage sensors, but we did not surface those elsewhere. So if you are looking for a VRM, a voltage for an embedded VRM, for instance, or any other kind of motherboard related sensor for voltage, those are just available as a sensor. So you can certainly tell people to go look for them. We don't provide a convenience array, so to speak, elsewhere, because it just didn't seem like that was a popular implementation or something that we would expect client software to frequently pull on. So certainly looking for any feedback if we've missed something there. Power control was one of the more complex parts of the power resource. So that has been broken up into a couple areas. So the power limits, those move to the appropriate resources, and that's still some work for us left to do to find use cases where folks had specific power limits on a particular device, we want to move that to the device itself. The power readings and and other things that were in that power control array, those either move to the power supply or to an environment metrics resource, that is centered on any particular device. So as an example, you might have had a power control that was just populated to show the power consumption of a CPU. So that is now done with the environment metrics off of a processor. So that helped to clean up a lot of modeling, in the sense of trying to explain to folks, how did you map between these power control instances and what devices they were, actually managing. Well, now it's much clearer because the metrics for a particular device, like a processor or a memory DIMM, are directly subordinate to that, to that device. And so you don't have to do all this mapping and trying to figure out, by links and so forth, which one's which. So as I said, as we've started to do things with like the CPU, so that's where the environment metrics are. If there are other areas, that this was really trying to set the groundwork for future work. As we get requests for additional, places to drop in, additional valid locations for environment metrics, we'll certainly entertain those.
Jeff, we have a question in the chat we might want to answer before
Sure.
moving on. So the question is, to represent add-in card sensors, do we need to use the environment metrics? What's the recommended way to represent add-in card thermal power, voltage, temperature, and other metric sensors?
Oh, that's a great question. Yes, so we absolutely would expect you to put an environment metrics resource, for that add-in card. Mike and I can't remember if we put those under, I don't think we have them under network or storage adapter yet.
Not yet. We started with some of the very common places that people have asked for. So processor, memory, and drive were the critical ones. And we are examining other areas to add in those types of metrics. The sensors themselves, we're getting to the pattern of having the sensor resources within the appropriate chassis sensor collection. So if you need to have that kind of monolithic set of sensor readings, you have that one sensor collection to look at for that. But anything that's specific for that add-in card, you would represent in the environment metrics beneath that add-in card and possibly some components on that add-in card.
Yeah, so if you have add-in cards that have sensors that we need to expose, then please definitely give us the feedback as to what kind of card, and we'll make sure that we can get the links added to that. And at the end here, I'll point everyone back. We're always open for feedback. You can either take feedback through the DMTF portal, the feedback portal, for anything that's substantial. For small, simple asks like, okay, can I have an environment resources under a storage adapter? That's the kind of thing we can easily take and handle via the redfishforum.com message board, and we often we look at those every week, and generally folks that ask us for simple things, we can get those turned around in the next bundle, and as you know, we do those bundles 3 or 4 times a year, so it's usually a pretty quick, we can usually get ahead of your development and QA cycles. All right, so just in summary of all of that, so this is just a tree of what the new resources all look like. So you can see here the chassis resource. I don't know if I've got a point. There it is. Here's my pointer. So yeah, this is the chassis collection, and so as Mike said, here's a chassis resource. Here's the sensor collection, and some number of sensors that will all be centrally located for that chassis, and so. Where under the chassis would have, in previous implementations, you would have had this thermal and power resource. So those links and those schemas have been deprecated. And so then here you can see now the replacement, the power subsystem, the thermal subsystem, and then underneath, the thermal subsystem is the collection of fans and that summary thermal metrics resource. On the power side, there's the power subsystem. Under there is the power supply collection. So here are the individual power supplies, and then each power supply has its own metrics resource. That environment metrics, that does also show up on the chassis. So that's one of the first areas that expect to find, temperature sensors, humidity sensors. Very common to have those on a chassis. And remember, with the chassis containment model, this could be rack level sensors, just as a for instance. All right, so I'm going to move on. I'm going to hand it to Mike to do the other half of the new work.
All right, thanks, Jeff. So one of the other additions that's worth noting is we've extended the manager account resource to include additional account types. So taking a step back in time for what was first released in Redfish back in 2015, when you look at the session collection, all the members of that were very much focused on, these are the active Redfish sessions that are open with the manager. Over time, there was a desire to be able to expose additional types of sessions through that collection. So you could say, as an administrator, I'd like to go in and use Redfish as my one-stop shop for seeing all the types of connections open with the manager and be able to terminate sessions as needed. So you could say, you could make decisions like, I'm doing a critical operation on the host. I need to terminate all KVM IP sessions to ensure that no one is interacting on the host itself. And so they could go through the session collection, filter based off of the session type and terminate that session. Growing on that concept a bit more, there was a desire to have that same type of configuration presented through the manager account resources. So not just saying this manager account resource represents a Redfish account, but rather it's more of a general account for the manager, and you have a set of things that you're allowed to do with the manager, such as open up a Redfish session, open up KVM IP, use IP mine, so on and so forth. So one of the configuration options is to say, as an administrator, I want to make sure that this new account I'm creating, maybe I have some restrictions where I want to only allow Redfish operations on this manager account. Now, taking a step down into some potential architectural details for implementations, it may not be possible to restrict a given user account from certain other non-Redfish areas. It just might be fundamentally how the implementation is constructed. So in order to help clients navigate that type of tricky decision making, we've added in this strict account types property to let an administrator that's creating an account say, I want to make sure that you don't give me extra access beyond what I request. If I want to make an IPMI only manager account, I want to make sure that the account created is only given IPMI and doesn't bring in additional capabilities. And so if the implementation is not able to satisfy that, it can return an error saying, I see you want this to be only IPMI, but I can't allow for that. That's just not something that we can do. Okay, next slide, Jeff. All right. Another big addition was the addition of this new conditions array in our common status object. So if we look at what's in the status object prior to this, we have state, health, and health rollup. Now, if you're trying to examine a resource and you just see your health is warning or critical, well, it puts a burden on the client to try to figure out why that might be the case. In some cases, it might be easy on some resources, like a sensor resource with different thresholds, and you can do comparisons of the reading against those thresholds, and it's pretty easy to figure out why your health might be critical. In other resources, trying to piece together that information could be difficult, especially when you start thinking about scenarios like, maybe you have uncorrectable memory errors. Do I need to go over to a metrics resource and start looking at ECC counts, or are there PCIe errors that are occurring in the system? And so we decided to add this conditions array to act as a set of messages that describes why the resource is in a non-okay state. One thing to stress here, though, is that this isn't a replacement for an event log. While the constructs make it look like it could be a log, the reality is it just shows the active states on the device itself. And so if there was a condition that were to clear up, then the respective message for that condition would also be cleared. We decided to put this within the status object because it's just one of our common building blocks that we put everywhere in the data model. So every resource can benefit from this extension. Another thing that was needed to help convey additional information for this was the fact that maybe the health of the resource is being affected by another resource, and so you might need to redirect the client to say, yeah, I'm bad. So my overall storage subsystem is bad because I have a faulted drive, and here is a reference to that drive that might be faulted. And so this basically gives a way for a client to start looking at an individual resource within and seeing its conditions, and in the end, being able to follow the path to other particular resources that are affecting it and make corrective actions as needed. All right, next slide, Jeff. So this is an example of what the conditions array look like. And so we have our common status object with health, rollup, and state. Health is critical in this case. And so as a client, I'd like to see why the health is critical. And so stepping through the conditions array, I start seeing a set of messages. So using the normal type of message semantics that we use elsewhere in the data model. So again, stressing the fact that this might look like a log because it has a timestamp associated with it, and it has a event messaging that we also expect to find in a log. But this is really just to reflect the state of the resource, not to act as a log that you need to clear later. So we see a message ID in here. In this case, it indicates we have a degraded write cache, and it was first detected on November 8th, 2020. It gives us a human readable string that says, yeah, there's a storage controller located in slot 4 that's degraded, and that's why this resource is in this critical state. And if you want some more information, we also have a log entry to show when that event was first observed. So that way you can correlate your conditions to a history of events that happened in your system. We also see an additional message in this conditions array to show, yeah, we have a condition in another resource, so it's related to this, and you should probably move over to that origin of condition to see to get some additional information about what went wrong. In this case, it says, yeah, there's a related condition that's found in drive 9 on my chassis called 1U. And so if you go over to there might be some more information that is relevant to why this storage subsystem is in a critical state. All right. So the other material that we've published as a part of the 2020.4 release, we get into the habit of having a schema guide, property guide, and schema supplement. These are all documents that get produced based off of the text that goes into the schema bundle. So DSP 8010 has a lot of descriptions. It's all schema, and so it's not always the easiest to read from a human perspective. And so we have tools that will automatically take that schema bundle and produce appropriate material that is easier to pass off to developers or other humans to digest. So we have an informative document called the Redfish Resource and Schema Guide. So this presents all the descriptions of all the resources. It has example payloads in them for what each resource looks like, lists out all the different properties you can find in those resources, and describes them all. So it tries to tabulate it so it's easier for a human to read. Likewise, there's a similar informative document called the Redfish Property Guide. So it takes listing, just a flat listing of all the properties we defined in Redfish, and tries to compile effectively a single database of, here's a list of all the properties and all their descriptions. So tries to help us prevent redefining properties of the same name, so that way we're consistent in the data model. And then lastly is the Schema Supplement, which takes all of our normative descriptions, so the long descriptions in our schemas, to create the normative standardized hardened text around how each of the properties are implemented. And so this is used by developers to ensure that what they're developing against is consistent with expectations from the forum. Okay, so that's it. I think we can open up the floodgates for Q&A at this point.
Yeah. Thanks, Mike. So as we kick off the Q&A, Shannon, if you can put out our first poll item. We wanted just to see who's in the audience, and what brought you here today. So if we can get that first poll question up there. And we'll just give folks a few seconds to get there. And Mike, the first question that we had come in was asking is there a plan to provide a mock-up for the new Power Subsystem and Thermal Subsystem to reflect those new changes? And if you have your browser handy to pull that up.
I can show this.
So the answer is absolutely. We absolutely expected that was going to be something that would be of interest. And so Mike is showing there.
So I guess one thing to preface this is we have a mock-up bundle that we periodically publish under DSP 2043, I believe.
Yes.
And so we did update that, in particular the simple rack mount server mock-up to show the new power and thermal model. So if you step into the simple rack mount server, you go into chassis, you go into chassis 1U. And we can see in here, we have the new thermal subsystem, power subsystem, environment metrics, our sensor collection. We also are still carrying around the older power and thermal model, just because we expect that implementations will likely need to carry both for the foreseeable future until the industry matures enough that we think clients are ready to migrate over completely. But we also have this deprecation text. This is legal to do in your implementations. You can annotate properties with redfish.deprecated and say, where do you want to migrate to? So what should you be using instead? So in this case, we're giving the recommendation to migrate to using the thermal subsystem in favor of the existing thermal model.
Great. Thanks, Mike. All right, so let's see. Our poll results say that we have a lot of folks. 62% of the folks on the call were doing a Redfish implementation on their products, so that's great. And we also have about a third of the folks are end users or DevOps personnel. And wow, and no one accidentally came here thinking this was a phishing show. So that's good news, or bad news. I don't know. Okay, so if you have a question, there's a Q&A button there in your Zoom interface that you can type a question in, and we'll get to those. So I see we've got one in here. Let me just read it here. This is from Joe saying that he is a software architect and DMTF member, would like to make suggestions on updates to the schema. For example, adding a new RAID type enum. Yeah, so there's two ways to do that. So Joe, if you're already a member company of the DMTF and the Redfish Forum, then by far the best way to get that feedback in is to talk to your representatives. If you're actually a member of the forum, then go to our internal GitHub and just open a new issue asking for that as an enhancement, and that's stuff that we look at several hours every week. For the folks that are not DMTF members, then we have the Redfish specification forum, so that's right there at redfishforum.com. We as a group go through every public post every week, sometimes faster than that. to answer any questions or to take small suggestions and comments. If you come into the Redfish, if you come into this public forum and ask us for an entire new schema of new types of devices, we're probably going to redirect you to the DMTF's feedback portal to make that as a formal submission, which is necessary for the standards body work, especially as when it comes to copyright law and so forth. But we'll walk you through that process if it comes to that.
One other thing to add, at least specific with that example, I gave RAID type. Unfortunately, RAID type is in the volume schema, which is owned by SNIA at this time. But the good news is the same form is used for swordfish tracking. So you can also make requests to Swordfish to add in those types of extensions as needed.
Yeah, and there's a feature request one that looks like it really could use another thread. So. Great, thank you for the question. So let's see, the next question that came in was, is there a mock-up available for the Redfish PDU model?
Yes, as this was also put in. So one of the newer mockups that we released as part of the new 2043 bundles is power distribution unit mockup. So like with other mockups, you can just go explore it, and if the page loads, here we go. Here we have our power equipment resource off of service route. So if we step into there, we can see the different classes of PDUs that are being tracked. And so there are multiple PDUs in this mockup. And so if you want an example of a rack PDU, you can click over to the rack PDU collection and see that we have one rack PDU, and there's a bunch of circuits associated with it, some outlets, outlet groups, metrics, and sensors, and so forth. So yes, if you go to the mockup page and look for power distribution unit, you can find example PDUs.
Great, thanks, Mike. Let's see. So another question was, is there general guidance on how to determine whether a given device supports the new or old schema definitions? For example, the power versus power subsystem. So from a client perspective, the way to do that would be to first attempt to read the power subsystem schema. And so if you don't find it there, if you don't find the power subsystem, then you would fall back and go to the power, the power resource. And Mike will walk you through here on this rack mount server. So the idea is that you go try the new the new version, and if it doesn't, then you fall back and use the old. And that way, folks that have implemented both for the sake of client compatibility, you won't miss out on functionality. So it's certainly easier to navigate the new pieces, but the information is. It should be the same, and what we have guidance we've given folks is that if you are implementing the new power subsystem and thermal subsystem, you should do that entirely. In other words, don't do the power supplies but not the power controls. Make sure that if you're replacing it, to replace it 100%, so that we can tell clients exactly that.
I guess one thing to add on there is, like with a lot of other properties in Redfish, the way most clients detect whether or not something is supported is the presence of a property. So if you go to your respective chassis resource and you don't see this power subsystem property, then it does not have the new power model.
Yeah, that's a better succinct answer, Mike. So another question was, can we expect the OCP Redfish profile compliance to reflect these new changes when published? Did we open issues or roll those into changes in OCP? So the work has been published, so that all of these models are available. This was part of the 2020.4, and that was made available in mid-January. So that this is all final and produced. And by final, I mean we've shipped version 1.0. So we're already working on additions for the next release to add minor improvements. In terms of OCP or the Redfish profiles, it's going to take a while for us to see a large amount of implementations of this new model, and so we don't want to do we don't want to make folks non-conforming to those profiles, because they're already shipping firmware or had things in flight. So I think what we will probably recommend for the OCP folks will be to, to make the new models recommended, or to say that you have to have one or the other. And then over time, we'll certainly encourage folks to be doing new implementations on the power and thermal subsystem models. And certainly any kind of product class that did not have those implementations currently, I'm thinking like an Ethernet switch, for instance, that might not have implemented, from a Redfish standpoint, may not have been around long enough to have that level of detail in power and thermal. Well, then then those models and those specs should all just start with the new model. But it is a migration. We expect that to take some time. But as I said, they can coexist, and so that's probably going to be our recommendation for at least a year or two. All right. Well, let's see. We've got looking for other questions. While we're waiting for any other questions to come in, Shannon, why don't you throw in our second poll question here? Again, this is just a quick one, is to so before you got here today, what was your familiarity with Redfish? And we'll give folks just a few seconds to give that one a try. All right, let's see, I'm going to pull this up. I've got that waiting as well. All right, Shannon, if you can finalize that poll, we'll take a look at those results. So just as a conclusion, just we've still got time here. We can take more questions, obviously, but just wanted to have this slide up for everyone to be able to know where to get further information and to get further involved. So the standards page on the DMTF site, that has all of the links to download the actual materials in terms of the specifications, the schemas, anything that's a downloadable is there. The one-stop shopping is at the Redfish developer portal, which is redfish.dmtf.org. So that's where Mike was showing you the online resource explorer that had those mock-ups available. And then we have links to everything else Redfish related, be it the standard, the public forum, the GitHub repos. Everything is linked from the developer portal. So you can go there. And as we said, the user forum is absolutely available for public comments and feedback and questions. We try to get those answers to everything that's posted there. And if you get real serious, need to put something into the feedback portal, there's a link there to show where that occurs on the DMTF site. And lastly, put out the word, come on in, the water is fine. It's a tropical environment where the redfish live. So please join the DMTF and the Redfish Forum. If you have any development in any of the product spaces that are covered by Redfish, I can guarantee you that the cost and time is well worth the R&D return on investment. So, all right. So given that, we've got kind of looks like a pretty good mix of folks that came here that were either just getting started or had written some code. So all down the kind of split here all four ways. So a good mix of novice and experts. So thank you all for attending. Let's see. Last one. Let's take. We are interested in the open source usage. So Shannon, if you can put the last of our poll questions up. So the DMTF publishes tools on GitHub, and so we'd just like to know, are these of interest to you? Which areas? And if this is the first you're hearing about it, we want to know that as well. So we'll give that just a few seconds, and as we let you finish that one, when we conclude this webinar, like I said previously, we will make a recording available that'll be on YouTube under the DMTF channel, and also as we conclude, there'll also be a very brief survey that will pop up in a web browser. If you wouldn't mind telling us what you thought and what you'd like to see in in future webinars. We'd very much appreciate that. All right, Shane, let's take a look at the results of that poll. All right, so about half the folks had already knew about that, and we're looking at the conformance tools, which are great. It's been the number of bugs that those conformance tools have pointed out in all the implementations that we have checked. It's amazing how quickly you can fix stuff, and how complete those tools have become over time. We develop them and continuously improve them, and also do a lot of plug fests with donated equipment. And so we're constantly testing those and improving them to make sure that they work, and also obviously giving feedback to the vendors doing implementation, so that what we're producing is a true interoperable standard. All right, and for those of you who hadn't seen that, I didn't put a link to there, but it's github.com/DMTF will get you to all of those repositories. Please feel free to take a look at those tools. And again, that's all open source, so you're welcome to contribute or ask us questions, or look for enhancements on those. So. Like I said, we're very open to feedback, and try to be very responsive. And the whole point of this standard is to make the data available and usable by end users, across vendors, so that we can actually get some real work accomplished, right? All right. Well, with that, do not have any other questions in the queue. So unless we see any other hands come up here in the next couple seconds. Not seeing anything. All right. Well, thank you very much, folks. I hope this has been useful for you. On behalf of myself and Mike Ranieri and all the members of the DMTF and Redfish Forum, thank you for attending, and everyone have a good night.
Thanks, everyone.